Hello and welcome. In this session, we will be looking at probability. We'll be looking at the sample space and events, finite probability space, conditional probability. All right. So those will be our focus for today. Probability may be viewed as possibility. It is a branch of mathematics that deals with the occurrence of a random event, how likely an event is to occur. This can be determined through the use of probability. The value of the probability is going to be a number between 0 and 1. All right. So probability, as mentioned earlier, is used to predict how likely events are to happen. And this is a technique that is used a lot by persons who are in gambling and persons who are into investment and so forth. Now, in order for us to understand probability fully, we need to understand what an experiment is. And an experiment is simply a process that yields an outcome. All right, a process that yields an outcome. That's what we refer to as an experiment. And here we have two. Rolling a die. So if we were to take a die and roll it, that would be an experiment. If we were to make a selection of 5 microprocessors from a lot of 1,000, again, that would be an experiment that we could carry out. All right. Now, the next thing that we need to know about is event. An event is simple an outcome of an experiment. So if we roll a die, what are the different outcomes that we may have, right? So any of those outcomes, when you roll the die, forms, an event, all right? If you were to make the selection of the microprocessor, any of the outcomes that you could get forms an event, all right? So for example, obtaining a 4 when we roll a die. Remember, the die has 6 faces. So if you were to roll the die and end up with a 4, that would be an event. All right. Obtaining non-defective microprocessors, when you select 5 from a lot of 1,000, that would be another event. All right. Now, the next thing that we need to know about, very important, is sample space. And the sample space is the possibility of all outcomes, all the possible outcomes that we can get when we carry out an experiment, all right? So all the possible events that we may end up with, right? All the possible outcomes when we carry out a particular experiment. So think about it, rolling a die. If you roll a die, since there are 6 faces, the possible outcomes are going to be 1, 2, 3, 4, 5, and 6 coming up, all right? And then for selecting the 5 microprocessor, all the possible outcomes of selecting the 5 microprocessor, that will form the sample space of that experiment. All right. Now, to calculate the probability of an event, we simply divide the event by the sample space. We simply divide the event by the sample space. Now, assuming that all outcomes are equally likely to occur, when all outcomes are equally likely to occur, now if there are n possible outcomes, that means if the sample space is n, then for each one of the event, right, for each possibility, there is a probability of 1 over n. All right, so here's an example of an experiment where the outcomes are all likely. So for example, let's say we flip 2 coins. If we were to flip 2 coins, then there are 2 possible outcomes. The possibility of getting a tail or getting a head, all right? So since there are 2 outcomes, then the sample space is going to be 2, all right? So in this case, our sample space is 2, all right? Now, the probability of getting a head is going to be simple 1 over 2, all right? So since the sample space is 2, because there are 2 possible outcomes and there is just 1 head, so it therefore means that the probability of getting a head is going to be 1 over 2, all right? Good. So the probability of getting a head in this case would simply be 1 over 2, since there are 2 possible outcomes. and there's just one head, so it's 1/2. All right. Similarly, the probability of getting a tail would be 1/2 because there's just one tail. Now let's look at another example. Now, what is the probability of getting a head and a tail when two coins are flipped? Now, if you notice, looking at the right of your screen, you notice we have two coins over there. And with these two coins, we have two heads and we also have two tails. All right. So since we have two heads and we have two tails, it therefore means that we have a total of 4. All right. So we have a total of 4 possibilities for this sample space. All right. So we have a total of 4 possibilities for this sample space. Now, how do I know that it's 4? So think about it. So let me just bring up my pen. All right, so we have the $10. So whenever we get the $10 tail, so if we have the $10 tail, we have the possibility of the $10 tail along with the $20 tail. And we could have the $10 tail along with the $20 head. All right. Okay, so we could have the $10 tail along with the $20 tail. We could have the $10 tail along with the $20 head. Another way that we could have is so these are 2 possibilities. So we could have now the $10 head. So we could have the $10 head along with the $20 tail. And we could have the $10 head along with the $20 head. All right. So those are the possible forms that we could have this in. All right. Having established that a sample space is 4, because we have 4 different arrangements that we could have. Now, what is the probability of getting a tail? A probability of getting a tail when the 2 coins are flipped. All right. That's the probability of getting a head and a tail when the 2 coins are flipped. All right. So let's look at it. So we have a total of 4 possibilities in terms of the different arrangements that we may have. All right. I'll just write it on the screen so we can have a little more visual. All right, so I hope this is a bit clearer. So these are the 4 possible outcomes that we could have when we flip 4 coins. So 2 coins rather. So we could have a tail, then a head, a tail, another tail. We'd have a head and a head and a tail. All right. So there are 4 possibilities. So the sample space is 4. Now, what is the event? So the event is getting a head and a tail. So let's count how much head and how much tails we have in the possibilities. So we have 2 possibilities of getting a head and a tail. So in this case, our event is going to be 2, all right? Which therefore means that the probability of getting a head and a tail is going to be 2/4, all right? It's going to be 2/4, which is the same thing as a half, okay? So that's how we go about working out the probability of getting a head and a tail. All right. Now let's look at another example. Now let's say we have 2 die and we were to roll these 2 dice. So the question is, what is the probability that the sum of the number on the die will add up to 10? What's the probability that the sum of the numbers on the die will add up to 10? Now, first of all, we have to try to establish what the sample space is. So if you roll 2 die together, all right, so these are all the possible outcomes. I list them out on the screen so we can actually visualize them. So we could end up with the black die being 1 and the white die being a 1. We could end up with the black die being a 1, the white die being 2. While the black die is 1, the white die is 3. While the black die is 1, the white die is 4. While the black one is 1, the white one is 5. While the black one is 1, the white one is 6. And as you can see it going down, all right? So these are all the possibilities. When we add them up together, we have a total of 36 different possibilities that we could have, all right? So it is 6 times 6, all right? So because you're rolling 2 dice and each die has 6 sides, all right? So to get a total sample space is simple 6 times 6, which is 36, all right? Now what we need to do now is to identify how many times or how many of the combination adds up to 10. So let's see. And that is going to be our event. So let's go through each row or each column. And we're just going to mark the ones that add up to 10. All right. So far, this is not 10. So none of these adds up to 10 in row 1. Let's look at row 2. Nothing here adds up to 10. Row 3. That is nothing. This is 8. And this is 6 and 3. Nothing there adds up to 10. All right. This is 8, 9. This is 6 and 4. Of course, here's 1. So this is 1. 6 and 4 is going to give you 10. Let's go down here. It's 5, 7, 6, 7, 8, 9. Okay. Let's look down here now. We have 5 and 4, 9. 5 and 5 is 10. This is another one. All right, let's see. 6 and 1, 6 and 2, 6 and 3, 6 and 4. Yes, 6 and 4 are gonna give you 10. All right, so 6 and 4 is 10. All right, so you can look if you find any other. So there's no other. So we have 3 different possibilities that will give us 10. So now with a sample space of 36 and an event of 3, let's see what our probability is going to work out to be. All right. So the sample space 6 times 6, because we have 2 die with 6 faces each. So our event here is 3 because we have 3 different sets or 3 of the outcomes that add up to 10. And so the probability of getting a 10 is going to be 3 out of 36, 3 over 36, which is the same thing as 1 over 12. All right, so that is how we would go about working that out. All right, great, good. All right, so here's another example. So let's say we are asked to work out the probability of selecting 5 microprocessors at random from a lot of 1,000 microprocessors. And we are told that 20 of the microprocessors are defective. So 20 of them are defective, and we are told to find the probability of obtaining no defective microprocessor. All right. So obtaining no defective microprocessor. So if 20 of them are defective, then how much of them are not defective? All right. So 20 of them are defective. That means we have a total of 980 that are not defective. All right. So it's going to be 1,000 minus 20, which is 980. That is not defective. So we are asked now to work out the probability of choosing 5 microprocessors from a lot of 1,000, among which 20 of them are defective. So the probability of selecting a microprocessor that is not defective, so find the probability of obtaining no defective microprocessor from a lot of the 1,000 microprocessor, of which 20 of them are defective. All right. Now our sample space is going to be all the possible microprocessors that we can select from the lot of the 1,000. So that's our sample space is going to be 1,000, choose 5. Now our event, since there are 980 that is not defective, so our 5 will be chosen from the 980. So we're going to have 980, choose 5, and that is going to be our event. So this is going to be our event, while this be our sample space. All right. Now let's see. Now when we work this out, so our event being 980, choose 5, and our sample space is going to be 1,000, choose 5. When we divide those, we will end up with a total of 0.9 for our probability. All right. So we'll end up with a total of 0.9. So you can work that out on your own, and that would be the probability. All right, good. Now there are cases where the probability of the events are not all equal. So when all the probability are not equal, then we will have to use some form of function to actually achieve the probability. All right. So we're gonna take a look at situations where all the possibilities are not equal. All right. So like when we roll the die, the likelihood of getting a 1 or is same thing as the likelihood of getting a 2. When we flip a coin, the likelihood of getting a head is the same thing as the likelihood of getting a tail, and so forth. It's not always like that. So the world is not always level. All right, we're not always on a level playing field. And in gambling, you'll hear where persons load the die so that the likelihood of one side showing up increases. All right, so persons can build the dice that way. It's a form of cheating, which is not really good. All right, so we're going to look at how we could work out the probability when all the outcomes are not equal. All right. All right, so the probability function we have, P, is going to be worked out as follows. All right, so the probability of all the outcomes should add up to 1. All right, so the probability function P assigns to each outcome X in a sample space a number, P of X, so that P of X, the sum of all the values of P of X, will be 1. So simple put, all the probabilities should add up to 1. All right, so we look at an example. All right, so this is simple saying, so all the probability of X, all of the, when you add them all up, you should end up with 1. All right, and we're talking about values between 0 and 1. All right. Now, suppose that a die is loaded so that the sum of 2 through to 6 are equally likely to appear. So here's an example. Suppose a die is loaded. And let me just write this on the screen. All right, so we're saying that suppose that a die is loaded so that the numbers 2 through to 6, they're likely to occur on this. So it's going to be the probability of 2, same thing as the probability of 3, because since the numbers are equal likely to occur, the probability will be the same. The probability of 4, so all of these are equal. Probability of 2 through to 6. probability of 5 to the probability of 6. All right, so these are equally likely to appear. But that the probability of 1 is 3 times as likely as any other number to appear. So we can just choose any number. We could choose 2. So we're saying that the probability of 1 is 3 times the probability of 2. All right. So what we can do now, given that the entire probability should sum up to 1, we can then express everything in terms of the probability of 2. All right. So since all the probability should add up to 1, so we're saying that 1 should be equal to, so the probability of 1, so let's start with that. I'm going to write everything in terms of 2. So it's going to be 3 times the probability of 2 plus probability of 2 plus the probability of 3. And the probability of 3 is the same thing as the probability of 2. So you're writing down everything in terms of the probability of 2 plus the probability of 4, which is the same as the probability of 2. And for 5 is the same thing. Plus probability of 6 is same as probability of 2. All right. So we could even shorten this. Let's see how much different probability of 2 we have here, which is 1, 2, 3, 4, 5. So we can say 1 is equal to 3 times the probability of 2 plus 5 times the probability of 2. All right, we add these together, we get, this is 3 times the probability of 2, 5 times the probability of 2. So that leaves us with 1 is equal to 8 times the probability of 2. So from this, we can work out what the probability of 2 is. And so since we're trying to find the probability of 2, we can just divide here by 8. Or divide both sides by 8. Therefore, means that the probability of 2 is equal to 1 over 8. All right. So the probability of 8, sorry, probability of 2 is 1 over 8. All right. Now, if we know what the probability of 2 is, that means we can write down what the probability of the other stuff are. So therefore, can conclude that the probability of 1, but the probability of 1 is equal to 3 times the probability of 2. So it's going to be equal to 3 times 1 over 8, which is equal to 3 over 8. And we know what the probability of 2 is, and probability of 2, probability of 3, all of these are the same. So the probability of 2 is 1 over 8. Probability of 3 is 1 over 8. Probability of 4 is 1 over 8. Probability of 5 is 1 over 8. Probability of 6 is 1 over 8. All right, so that's how we work out the probability when all the outcomes are not equal. All right. So that's how we would work out this one.